Hello everybody, you just completed your first self-designed experiment in science class. We're going to be doing this a lot this year. It's pretty neat because you get to choose your own dependent variables and then do your own experiment. And then at the end of every time we do an experiment like this, you get to write a quick little report. Now the reason we write reports in science class is to make sure, first of all, that you understand what you did. It helps you better organize your thoughts and your analysis of the experiment that you did. And also, when real scientists do science, they have to write it up into a report and then send it to scientific journals to publish and share with the rest of the world. So we actually organize our scientific papers and our reports the same way that real scientists do. First, they have a title. They have this thing called an abstract, and we'll review that in a second. Then they have an experimental design, which shows people how they designed their experiments. Then they have some sort of data where they analyze using some sort of graph or something what they did. And then a conclusion, like what happened and maybe what can we do next time for our next experiment. I want to let you know that you've already done the hard work here. You've designed your experiment. That was the hardest part. You've, of course, by now done your experiment, and so you should have all of this filled out, including the experimental procedure and the data table that you've drawn here. But let's go through how to write a science report. All right, in here we've got what we call a rubric. All of these things are worth 1 or 2 or 3 points, and they'll be put into your science report here. Let's kind of go through them one at a time and make this quite easy for you, especially the first time that we're doing this here. All right, first one. Your report should include the following in separate sections: title, abstract, experimental design, data, and conclusion. Since I've already printed this out for you, that's already done. Go ahead and give yourself 1 point. Way to go! All right, title. Your title describes the investigation in a few words. So if you did an experiment, kind of like mine, this is just the example I showed in class, where we change the type of material and we pick up a certain number of papers, then your report title could be something like how type of material affects static electricity. Don't make it too vague, like static electricity report. That's kind of boring. But don't make it too specific that this is a whole paragraph. Just have it do something with what you put here. And once you've got it, give yourself a point. Good job. All right, the abstract is 3 sentences. An abstract is basically a short mini paper where you are telling the audience, or whoever's reading this, basically, what did you do, what did you think was going to happen, and what happened. Scientists do this in their reports because science papers can be quite long. And if you just can quickly read that, you can tell what the paper was about. So, the first sentence in the abstract, here's abstract, is what's the purpose of your experiment? It says describe the purpose of your experiment. It's worth 1 point. What could that be? You've already done it! Look, right here. The purpose of this experiment is to determine how the type of material affects the number of papers picked up. So you literally will write that sentence right here. The purpose of this experiment is to determine, anyway, it's this right here. That goes there. Boom, 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 boom. All right, what was your hypothesis? You should have put your hypothesis right here, where you drew a graph or something with 3 bars on it, and maybe you thought the more you rubbed, the more papers it would pick up, or the different material, like I thought maybe wool would pick up the most. That's your hypothesis. So our hypothesis was that the wool would pick up the most papers. Whatever your experiment's about, put your hypothesis there. In the end, what actually happened? Okay, well, you should have done that. You should have done that. Briefly state what you found or learned in the end. What was the takeaway idea? What happened in the end? So just say, in the end, blah, 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 picked up the most papers, meaning that the balloon had the most static electricity. That would be this one. Boom, boom, boom. You got it. All right, moving through this. The experimental design has 1, 2, 3, 4, 5 sections. So 1, 2, 3, 4, 5. Let's start with the first one. The materials we used were, and it says describe all the materials you used. So we used balloon, paper. We used the fabric sheets to remove the electrons in between each trial. And what else did you use? Maybe you used different fabrics or different people's hair. Okay, that's just the materials you used. Give yourself a point if you did it. Describe your procedure. This is kind of the steps in a shortened version. To collect the data, we first rub the balloon on, I don't know, somebody's hair, and then we counted the number of papers that it picked up. And then we removed the static from the balloon and repeated that 2 times, and then we did the same thing on these 2 things. Or whatever you did, just describe your process there. Once you've got it, boom. Independent variable, dependent variable, controlled variables. You should have all of those right here. Independent, dependent, and controlled variables. So our dependent variable is the type of material. Our dependent variable was the number of papers picked up. Some controlled variables are, and you should have listed 4 there, so you can list 4 things right here. Once you have all those, boom, boom, boom. Okay, data. This is where things can get a little bit tricky. In the future, like this is the first one we're doing on paper, the rest will be on computers. I'll have you actually build graphs in the computer and copy and paste them into your Word document. But for now, you'll need to build a data table. Or, sorry, not a data table, a graph. Your graph will look something like this, where this will be the number of papers picked up. And you'll have to see what was the maximum number of papers you picked up. Maybe it was 15, you put that at the top, or maybe it was 10. But you got to make sure this goes up high enough to actually show the highest number of papers that your thing picked up. Then we'll need, depending on your data table, and your data table can go right here, depending on what that looked like, your graph might be a little bit different. For the example one that I did, we did cotton shirt, we did wool shirt, and we did polyester shirt. And we did trial 1, trial 2, trial 3, and then the average. So we need to see, we're looking at this number right here. Once you get the average, and you get the average by adding these up and divided by 3, these are the 3 things that you're going to graph over here. So I don't have any data, I haven't done this experiment, but let's say on average the cotton picked up 8 papers, the wool picked up 10.5 papers on average, and the polyester picked up 5 papers. Well, then the highest number I need to graph is 10.5. So I need to make sure my y-axis, which is the number of papers picked up, I need to make sure that goes up to 10.5. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I don't even need those. Oh, 11. Okay. So the cotton will go up to 8. And I can label that cotton. The wool will go up to 10.5. And this doesn't need to be exactly perfect. Just do the best you can. Wool. And then the polyester will go up to only 5. 1, 2, 3, 4, 5. And I'll just put polyester. And then down here I'll label this material. Now you have a graph and a data table. And if you have both of those based on your data and your experiment, give yourself 2 points each. 1 for the data table and 1 for the graph. All right, we're getting close here. We have a conclusion. The conclusion has 3 questions or 3 parts. So in the end, let's answer these questions. Summarize the data. What did you learn? How do you know? In the end, we found that wool picked up the most papers, meaning it has the most static charge. And then we're going to answer these 3 questions. Each of these 3 questions are worth 1 point. See, 3 points, 3 questions. First one, what is the structure of an atom and what parts cause static electricity? So I would say the structure of an atom is, and then answer that question. Once you've got it, you can give yourself a check mark there. Next, in your experiment, what was your dependent variable and what was causing it to happen? The dependent variable was the number of papers picked up. What was causing that to happen? That's your second sentence here. Answer that. What experimental situation caused the greatest change, the least change, and why do you think that is? This can just be a random guess. Like, I don't know. If wool picked up the most paper, I wouldn't know why that happened. So this is just kind of a guess. Maybe you know, or maybe you can look it up. But I think wool picked up the most paper because, and I don't know, I'd take a guess here. Okay, and then you give yourself 3 points if you did all those. Was your hypothesis correct? Why or why not? Our hypothesis was incorrect, or correct, whatever you thought. You know, it depends on how your hypothesis matched your data. And then because, and then answer the question because. And then one more. Okay, give yourself 2 points for that. Were there any errors or changes you would make, or something you would do differently next time? What happened in your experiment? Do you think everything worked out perfectly? Do you think, like all the papers were the same size, the balloon acted the same way every time? Were you able to get the electrons off in between each trial perfectly every time? Probably not. Every good science experiment has something that's not quite perfect. That's what we're talking about here. And it's not that you're wrong or you did something bad, but errors happen. They're just called human errors, and it's just part of living in an imperfect world. So if we were to do this experiment again, what could you do differently? Or would you like to try something else, different materials, whatever you think? Okay, this is your science report. And this, make sure you have this. This is going to help you write it. Once you think you've got it all, well then, boom, you have a beautiful report ready to share and ready to turn in. Any questions, let me know, or rewatch parts of this video, whatever you need. Good luck. You got this.